Okay.
Okay. So thank you, actually, guys, for coming, for braving this unusual format for an interview talk. Suman Maity is actually being considered for a postdoc position here at SI on our projects involving behavioral analysis and social media analysis. And he is actually, the reason he's working remotely is because he's finishing his PhD at IIT Kharagpur, studying exactly the kind of topics that we're interested in researching here. And so he will give a talk here, understanding content popularity and detection of malicious behavior in social media, which sounds very familiar to all of you. And so there will be some probably technical issues with, so maybe if you have some clarifying questions, because it looks like there's a bit of a delay. You can ask clarifying questions, but otherwise maybe we should follow all the other questions until the end of the seminar. Okay, Suman, the floor is all yours.
Okay. Thank you, Christina. So thanks for coming to my talk. I'm Suman Kalyan Maity. I am currently an IBM Ph.D. fellow and Microsoft Research India Ph.D. fellow at IIT Department of CSE IIT Kharagpur. So today I'm going to talk about my current research agenda, understanding content popularity and detection of malicious behavior in social media. Okay. So briefly to my research area, so I work in sort of interdisciplinary areas in the intersection of complex networks, data mining, NLP, and machine learning. So I'm publishing in the conferences like ICWS and CSCW and journals like EPL, PRU. Okay. So my research theme is currently broadly classified into understanding content popularity from the linguistics perspective, as well as understanding malicious behavior detection. So during most of my PhD, I was working on content popularity analysis, and currently with like about 8 or 9 months, I'm working on this malicious behavior detection, like the spammers, how spam spread in the network, how rumor propagates, and fake news, and this kind of stuff, with active collaboration from Professor Arjun Mukherjee at University of Houston. Okay, so in content popularity, I'm looking at hashtags in Twitter and topics. So basically, I'm looking at various social media entities. So for example, the hashtags in Twitter, the topics or tags in Quora or Stack Overflow, and the books in Goodreads. Okay, so why care about language? So language is important because the way we talk or engage with others create belongingness. Even for a platform like Twitter, there are several reports, and I'm citing one of them, and which blames abusive language, harassment, bullying, intimidation, threats for losing active users in Twitter. So language has some importance on popularity also, which I will try to show in my talk. Okay, so let's come into the specific research questions. So what are the factors that drive the competition and adoption of social media entities? Basically the popularity. What are the linguistic influences on popularity? And are there linguistic universals across several social media entities? Okay, so as I told earlier, I'll be looking into various sort of social media entities like hashtags, topics, and books. So specifically in hashtags, I'll be talking about, I was looking into a special kind of hashtag called hashtag compounding, where there are two hashtags. It's basically a phenomenon you can think of like lexical compounding also, or natural language word compounding, where two words merge together to form a new word. Here also in social media, we come across such phenomena, which is there are two hashtags which has been merged in latter time point to create another new hashtags, which is basically taking advantage of both the concepts. Okay, and also we are looking into idioms. Basically, this is another special kind of hashtags, which are basically conversational in nature. For example, 4 things about me, 5 words before breakup. So basically, these are as you can see from here, these are part of the sentences merged together to form a new hashtag. Okay, so I will be specifically in this talk focusing on hashtag compounds and topics in Quora, and try to find out. So basically, I will be presenting this to basically focus on the content features and basically the linguistic aspects which are driving the popularity of these kind of social media entities. Okay, so hashtag is everywhere. So we use hashtags in all kind of social media, from Twitter, Facebook, everywhere. So hashtag, and it has been used for multiple purposes, from politics to protest, from communalism, everywhere it's present. So due to this ubiquitous presence of hashtags, it has become language of its own. So that brings us to the first part of my talk, where I am looking into the early prediction of popular hashtag compound. So this work has been published in CSCW 2016 and has received a Best Paper Honorable Mention Award. Okay, so coming first to the basics of compounding. So the earlier compounding thing, the word compounding or the lexical compounding. So basically where the two words merge together to form a new word. So, and this kind of phenomenon is very, very prevalent across languages. So if you see English, French, and other languages also, these kind of, and in German specifically, there are evidences of a lot of compounds. Now, not all compoundings bear the same meaning when they're merged together. And in some cases, like when they're merged, after merging, their meanings get changed. For example, book and worm, they have two distinct meanings. When they merge together, they form another word called bookworm, which has a very, very different meaning. For example, light and house merged together to form lighthouse, which is also having a different meaning. So, if you want to study this kind of word compounding, there is a problem. So the main problem is the scarcity of data. We don't have historic data of evolution of language which captures this kind of phenomena. So this brings us to several open questions. Why compounding happens, how such compounding happens, and how are they adopted in a linguistic community. So in this talk, I will try to use hashtag compounding as a proxy for word compounding to study such behavior. So to reiterate again, so hashtag compounding is basically a special kind of specific kind of hashtag which is formed from two or multiple hashtags merging together. Here I give some examples. So in the left hand side you see the hashtag beavers. So here I show some tweets. And so basically, if you use hashtag Beaver, you are basically referring to all kinds of activities of Justin Bieber. Now, if you refer in the right-hand side, if we are showing the hashtag blast, with which you can show all kinds of activities regarding birthday blast. Now, when these two merge together to form hashtag Bieber blast, it's a typical, a different sort of phenomena, which is basically when the fans of Justin Bieber tries to view a song or a record multiple of times to make it popular. So this is a very different sort of phenomena than the individual hashtags, which is making the new hashtag. Okay, so this hashtag compounding can also be thought of as concept merging phenomena. So where we basically have two general concepts, two or more general concepts, which has been merged together to form a specific concept. For example, we have hash Wikipedia and blackout, which are very general concept, and when they're merged together, they form a specific concept called Wikipedia blackout. Similarly, hashtag CSCW refers to a conference, and hashtag 2016 refers to all kinds of activities in 2016. Now, if you merge together, they specifically mention a 2016 version of CSCW conference. Okay, so we can also see this compounding phenomena as a competition of social conventions. So where we have two conventions, we can think of this scenario like we are given a choice where we can use the individual hashtags side by side or as a compound ones. So we have uncompounded conventions and compounded conventions. And not all of these conventions are equal popular. Some of them are and some of them are not. So we need to understand the popularity dynamics of such kind of compounding conventions or compounding in general. So where are these hashtag compounds being used? So there are a lot of places where it can be used. In marketing places, like for example, Amazon Prime Day, USD, Euro conversions, expressing communicative intents. For example, for political persuasions like hashtag President Trump, for humors, etc., you can use this kind of hashtags, or also due to spontaneous places. So basically, we have hashtags like hashtag the best feeling in a relationship, you know it's real when, hashtag relationship sticks. So these are, as you can see, these are a form of hashtag which I already mentioned to you. These are specifically idiom sort of hashtags and are sort of conversational in nature. Okay, so this brings us to another aspect of compounding, where you can, if you are looking into from socio-linguistic aspects, you can broadly classify these compoundings into two parts. One is spontaneous one are the influenced ones. So spontaneous compounds have lesser number of mentions per tweets and lesser number of collocations with other hashtags, whereas the influenced or the forced hashtag compounds, they spread via multiple mentions in early stage of propagation, unlike the spontaneous ones. So as I already said that hashtag compounds, so not all of these hashtag compounds are popular. So some of them are, some of them are not. So we need to understand the adoption or the competition behavior of this hashtag compound. So for this, we define popularity of hashtag compound as follows. So the popular hashtag compound, we define popular hashtag compound as the one where the frequency of occurrence of the compound hashtag is higher than both the individual hashtags. And in unpopular one, it refers to the case where the frequency of occurrences of the compound one is lower than both the individual hashtags. For example, I give some examples. The numbers in the parenthesis refers to the frequency of usage after 10 months from compounding. So we have popular hashtag compounding as high school memories, Operation Legalized Read, CNN debate, and unpopular ones as Love 1 follower, Hate Canada, Liquidation Monday, and so on. So here we look into specific research questions as follows. So can we systematically obtain early signals from data that differentiate this popular from unpopular compounds? And what features make this hashtag compound a popular? And can we predict with high accuracy whether a compound will eventually become popular early in time? And if you can do it even before the compound, that will be more helpful. So for doing this, we first do a linguistic analysis. So for this, what we do is we try to understand how the combinations of this compounding happens from analyzing parts of speeches, the named entities, and what kind of words to combine. Are the dictionary words or the new words like the celebrity names or the chatties kind of word which we find in social media. So parts of speech combination, if you look into this, so we have evidences in natural language compounding that noun-noun compounds are the prevalent ones, followed by the verb-noun, noun-verb, and the verb-verb. Now we also see in hashtag compound also similar kind of compounding happens. Sorry, similar kind of combination happens. For popular compounds, proper noun, common noun, determinant common noun are the more prevalent combinations, where for unpopular ones, adjective common noun, determiner common noun are the more prevalent ones. And if you see the distribution, there are distinctive patterns and they discriminate between these popular and unpopular ones. Now we look into the named entity combinations. So for this, we analyze the words in this hashtags. So, and then try to label it with different kind of entities. For example, person, movie, product, and things like that. And the most prevalent name entities which we found from this study are the person-person, product-product, and movie-movie combinations. Now, if you see this two distribution, you can find out that both the fractions and the orders of the combinations differ for popular and unpopular ones. So there are some distinctive patterns which is also evident from name entity analysis. Now we see which kind of words get compounded. So is it status word or the invocabulary words? So invocabulary words are basically the dictionary words, and here in refers to invocabulary words and OV refers to out of vocabulary words, basically which are not present in the current dictionary. And from the popular and the unpopular ones also, you see the rank order is different, as well as the percentage usage is also different. So this has also an effect on demarcating popular and unpopular hashtag compounds. So having studied that, so can we say, like, after analyzing these things, can we identify some features, some linguistic features, which will be able to predict whether hashtag compound will be popular than the both constituent hashtags or not? And that can be after we can do it at different time points. So think of a scenario like where there is an Amazon Prime Day sale going on, so you want to use hashtags. So you have choice. So you can use the compounded hashtags or the individual hashtag as Amazon has Prime Day. So to make your tweet popular, which variant you should use? So for this prediction, we have used several features. For example, hashtag content features, tweet content features, and user features. So hashtag content features are derived from the content of the hashtags. These are also, I have mentioned some of them also, like the person speech combinations, name entity combinations, out of vocabulary, in vocabulary combinations. And in tweet content, these are derived from the content of the tweets hashtag. And typical features are like word overlaps, n-gram overlaps, co-location frequency between the compounding pairs, word diversity, defining how diverse the words are, and how topical they are overlapped. These two compounding hashtags are overlapped. These are also relevant and important features for discriminating the popular and unpopular ones. In user, we are looking into discovering features from tweeting and mentioning behavior of the users. So we have features like number of unique users tweeting the individual hashtag, number of unique users being mentioned, and so on. So using these features, we can see that we can classify we can discriminate the popular and unpopular with a decent accuracy, with 77% accuracy when the prediction is after 2 months. And for long-term prediction, like 6 or say 10 months, we are getting a little bit better results. Okay. Now we come to the importance of feature groups. So I have told you that I have used several kinds of features like hashtag content, user features, and tweet content. Now, which kind of features are more important? Now, if we rank these features, we see that tweet content is the most prominent ones. And if you take them alone, they can give you 74% accuracy. And if you take all of them together, the tweet content, user, and hashtags, you get 77%. So the contents of the language of the tweet itself can determine very well the popularity of hashtag compounds. And we further to understand whether this problem is trivial or not. So we asked the user. So we asked many people in our group and across our institute. And there were 72 participants. So we asked them like, I will give you 2 hashtags, and I will tell you that they will be popular. They will be merging after say X months, and I will also its popularity is this much in this time point, and say a number at another time point. So can you tell me whether this will become popular after say another like t, if the initial time point is t, another time point is x, so after t plus x, what will be happening to this hashtag compounds? Now if we do that, do this experiment, the human evaluators cannot actually perform well. They are doing around like 40 to 45% accuracy. They're reasonably performing bad. But one interesting findings which we can found from this analysis is that they can identify correctly where the frequency gap between the between the compounded hashtags and the individual hashtags are more. So if you have a large gap between the popularity, the human evaluators can perform well. But in our automatic framework, we can also find out both the cases where there are differences, as well as if the differences between the compounded ones and the individual ones, if the popularity gap is low also, we can correctly classify them. Okay. So next I come to another topic, so where I will talk about the popularity of question topics in Quora. So this is also another social media entity which I'll discuss. So since I hope you are using the Quora for question answering, and it's really becoming popular nowadays, and since it started from like 2009, its popularity is on rise. So in Quora's ecosystem of knowledge sharing through question answering, topics play an important role. Now people follow topics to get important and valuable contents related to a topic of their interest. So for this analysis, since the Quora data is relatively difficult to obtain, so we crawl this by screen scraping. So we crawled Quora from June 2014 to August 2014 and obtained a data of over 4 years. So we have around like 0.8 million questions, 1.8 million answers, and roughly around 80,000 topics. So first we try to understand how topics behave in Quora. So for that we do a sort of temporal evolution of Quora topics. So first we see that the number of topics, if we see over the months, it's going to increase. And also if we see the number of new topics which are coming in, these are also increasing over time. And at the end, it's becoming sort of exponential behavior, showing exponential behavior. Now, if we look into the top or the popular ones, and if you try to see month-wise, like are these topics really becoming stable? Then you can see that though there are quite a huge overlap between these topics on top, but there is a significant number of new topics coming. The numbers being roughly between 12 to 20%. Now, if you see the temporal evolution of question answering shares among the stable topics, where the stable topics means that the topics which are occurring across all the time points. So by time points we mean the time unit is basically in months. So we divide the whole timeline into several months and try to do the analysis. Now, if you see, I have plotted the diagram, the stream diagram for various topics, and you can see that for startup topics, it was higher at the early time point, but over the time it decreases. Similarly, or unlike it, for the life and psychology topic, the number of questions or the number of shares increases over time. This occurs for the questions as well as answers. So from this we can infer that Quora is becoming more or less personal content, or possessing more and more personal contents. Now, to understand the dynamics of topical like migrations and popularity of these topics, we do a sort of intertopic dynamics, and where what we are doing is we create a network of the topics, so that the topics are acting as nodes in the network, and we create a edge between these two nodes if there are questions tagged by the same topic. And now we do a sort of case analysis of this topic. So we divide this whole, so we are removing nodes from the networks, and so basically splitting this whole network into different regions. And if we group this into equal size cells, for example, I have done it like from kmax to 3 kmax by 4, kmax by 2 to 3 kmax by 4, something. So basically equal sized partitions. And if you do a sort of analysis on these partitions, you can see that that there are several nodes in the core of the network, but in the periphery there are actually it's kind of unstable, and there are a lot of topic migration happening at the periphery. So if I explain this figure, so here the nodes in the blue region denotes the number of topics in that region, and the shades are basically mentioning the topics, the depth of the shades mentioning that how many topics are moving across various regions. So as you can see here, like the cores are more stable, where the periphery are unstable. Now here I show some example of topic migrations. So for example, you can think of pinned interest. So pinned interest was founded in March 2010, and as you can see from our analysis, in 2010 it was in the periphery of the network, and after that in 2011 it came to the core. Similarly, London Olympics was at the periphery in 2011, where there were little bit talks about London Olympics being going on. In 2012, it came to the core, and then in 2013 again it moved out of the core. So it shows a real nice behavior of topic migrations over time. Similarly, if we see the Mitt Romney case, so from the core in 2011, he came to from the periphery in 2011, he came to the core in 2012, where he was a US presidential nominee. But after that, after this US presidential election, he moved out of the core because he lost the election. So these results also corroborates from the Google Trend results, where you can see the popularity of various of these entities. So having said that, so can we here also do such kind of popularity prediction? So here we do this popularity prediction in two ways. So one we are finding features from the topics, and then try to use a sort of machine learning framework using SVR to predict the popularity of the topics. So basically, popularity of the topics is defined as, so in Quora is basically it's the follower count. So people follow topics in Quora. So we use that count as a popularity metric over here. And another popularity prediction framework we also did was where we have the questions with us. Then we do sort of a categorization of the questions to find out various sort of topics out of it, latent topics out of topic groups out of it, and then separately run our classifiers and try to predict their popularity. So basically doing a sort of popularity class predictions. For this analysis, we use the following features. We use context features, user features, and content features. So context features refers to the features which are derived from the questions and answers. For example, number of questions, number of answers per questions, average number of question views, shares, follow, and things like that. And in content, which is basically it derives from the content of the questions and answers. So here we are looking into topical question diversity, topical answer diversity. So it refers like how diverse the questions are, how diverse the answers are. And also we are looking into question novelty, which we defined as a KL divergence between the word distributions for the topics, for the words in the questions, as well as with refer to the whole word distribution among all questions in the net in our data set. So that gives you how diverse or how clearly identifiable these questions are. Similarly, we also define topical answer novelty or answer clarity. Also, we have the other features like pause diversity, linguistic analysis features like LIWC features like pause tags, swear words, and we also have some psychological categories like physical, social, optimistic, anger, and also emotions of which are being retrieved from this question and answer text. And then we use these features to do the prediction. So we have around 3,000 topics, and we use support vector regression, and we choose metrics as Pearson correlation coefficient and root mean square error. So as you can see, if we use all of these features, the content, context, and user features, we get around 0.77 correlation coefficient with a very low root mean square error of 1.06. Now, if we use content alone, we are roughly getting a very good accuracy, getting a correlation coefficient of 0.77. So content here also play an important role. And if you rank these features, as you can see in the right hand side, you see that most of the features belongs to the content category. And as I told earlier, we also did such kind of sort of categorization of topics. Now, if you do such kind of categorizations, there are sort of both improvement and improvement. So basically, in the categories where the topics are more aligned or more similar. For example, in the first cases, the topics are related to sort of technology, and since they're much closely aligned, for them we are getting a much better accuracy of correlation coefficient of 0.79, and for the cases where they are not much aligned, for them we are getting bad accuracy. So these suggest that we should try to analyze the topics in categories or in groups. We discuss about the hashtag compounding phenomena as social conventions. We also see the topics as social conventions in Quora also. So such kind of phenomena is also present in Quora. So here, to give you some examples, so here in Quora you can define your concept, define your topics. Unlike tags in Stack Overflow, where there are predefined tags which you can use in your question text. Now in Quora you can define your topics. So since it is being defined by human, and there can be multiple topics, which is essentially telling the same thing. So for that, the Quora system needs to figure out which of these conventions should be present in the system and which should not be present. So here we are doing a sort of an arly recommender system, which will sort of tell you like which of the topic conventions should be written and which you should discard. So this work is still. So basically, we have submitted this work to Dept of 2018, and we are waiting the results. So in summary, we observe that language is an important factor in popularity dynamics, and we see that there are presence of linguistic universities. For example, we have seen that features like diversity, pause tag diversity, topical diversity, which are also they are relevant in terms of in context of hashtag compounding as well as in context of in topical popularity. So there are university presence in this content features. Next, I move on to the understanding malicious behavior. So in this work, we are doing a sort of understanding on how we can detect spams early, how we can detect rumor in the network, and how we can stop fake news. So basically the spamming behavior, and also we are also looking into the soft puppetry. So soft puppetry is basically a phenomena where we have it's basically having a multiple aliases of a person. So how do I stop this person to stop this soft puppetry so that so that we can refine the system from this kind of pollution. So then we have this rumor spreading behavior and the fake news propagation. So in spammer detection framework, so we have designed a framework. So there were a lot of literature on spam detection, so which mostly look into from the contents perspective, looking into various content features and various also from the perspective of network, like how they are following and things like that. So here we are doing a sort of content as well as network based approach, where we are looking into. So this is basically, if you characterize this, we can characterize it into two parts. So we propose basically the first part, we have a follow spam detection algorithm, so which is a sort of a page rank based algorithm, and then we have a random walk based algorithm, which is basically leveraging this follow spam scores earlier detected, and then try to do a sort of biased random walks to generate embeddings. I will tell you in detail on the subsequent slides. So for this, let's see this example. So you have the node V here. Now, unlike the page rank, where we give higher weightage to the ones which are being followed by multiple people, here we want to give more weightage to the ones which are following more people, or basically following the more spams. So here the weightage, where the basically the scores are calculated from the P nodes which are surrounding this V node. So it's basically, it comes from the P nodes, and so basically these are the followings of P, and these P nodes give a part of their score to the V node, so that it can have. So it essentially says that if you follow more spammer nodes, you will get essentially a higher weightage. And this is the way it gives, the way P nodes give score to the V node is basically proportional to the number of non-reciprocal followership it has. Okay, so this basically explains the whole algorithm. We have a who follow whom network, and then we do a sort of page rank based algorithm, which is basically a follow spam detection algorithm. Now, once we have this follow spam scores in the network, we also try to use these follow spam scores to bias the random walks. So the basic idea here is, so we want to discover more nodes in the network, more spammer nodes in the networks. And if we do a simple random walk, we won't be able to do that, because we need, so the biased random walk guarantees that it will try to visit more spammer nodes in the networks. So here so basically we define the features from the edge weights. So we have various features like pitch frequencies, how they're mentioning each other's, and things like that. So we have several features, and then we try to find out a universal weight that will give you a sort of idea to bias the network. So bias the random walks in the network. So here we have the following constants. So for all the nodes in the network, so if it is a spammer node, the edge weight on the spammer to non-spammer node should be lesser than the edge weight on the spammer to spammer node. Similarly, for a non-spammer to non-spammer node, the edge weight should be less than the non-spammer to a spammer node. So basically, it's essentially saying that wherever you are in the network, you should do a random walk in such a way, or biased random walk in such a way that you end up with the spam, more likely ending up with the spammer nodes. So we also further bias this framework with another score, which is derived from the follow spam score, which is basically a combination. So we add up the follow spam score in the neighborhood of the nodes, and then find out a combined follow spam score, which also gives you sort of leverage to whether you should move on to the next spammer node in the network. So once we have this kind of biased embedding, sort of biased random walks, what we can do we can take advantage of frameworks like word2vec, where we have like in word2vec we have several sentences, and you can think of these random walks or those biased random walks as several short sentences. And if you have a collective set of such random walks, then we can learn an embedding out of it, which is essentially a biased embedding of the spam nodes in the network. And once we have this biased embedding of these nodes in the network, we can leverage this to classify the nodes as spammer or non-spammer. So we evaluate this system with other baselines. We also take into account the standard embedding frameworks like the DeepWalk, Node2vec, and other content-based spam detection algorithms, which are from like Benvenuto et al., Lee et al., and Ju et al. And we also use several traditional detection algorithm like PageRank. So basically here in PageRank we are taking the reverse. We are taking the nodes in the reverse order. So here we show the distribution. So the cumulative distribution functions, and we see that our method gives the best or the largest area under the curve. Okay, now we compare these models with other models as well as the precision at K, and we can see that it significantly outperforms the other baseline accuracies. So we have around like 10% improvement in terms of area under the curve and 4% in terms of precision at K. Okay. So let's move on to rumor spreading. This is basically a sort of work in progress. I will just give a glimpse of it. So rumors can be of various types. So we have several like celebrity gossips, rumor generating celebrity gossips, rumor during crisis events, and rumors creating crisis events. So basically, if you see like there are the rumors which are sort of celebrity gossips, they have only impact on the targeted person. Now the rumors which are created during the crisis events, for example a bomb blast or a terrorist attacks, they have huge impact on society. And the rumors which are creating crisis events have even higher impact on society. And they have like market influences, so they can spend in the society, even for them the stock market can plunge and so on. So here I give some example of such kind of rumors. So a shooting at La Hills during the Paris attack, so this kind of rumor can be classified as rumor during crisis events. A rumor creating crisis events could be an example. An example could be like rumor hijacking of WestJet flight 2514. So you got this rumor at around like in January 2015. Also, there was a rumor called Putin facing telescope in Moscow, so which has a lot of impact on society, and so there was lots of writings in news articles and so on. And particularly of interest is the explosion at White House rumor. So which shows that there was an explosion at White House and Barack Obama was injured. And this has a real implication that because it has crashed for a brief time period in April 23rd, 2013. So as you can see, this rumor which are creating this sort of crisis events has more impact, and we should early detect these rumors and remove this from the system. So the research objectives are early detections to stop spreading of rumors and understand the spreaders and the self-correcting behavior of the spreaders. So basically, so it's essential that we stop the rumor as well as we stop the spread. So because the ones who are spreading, if we talk to them, they will say that I don't know about that. I thought that it is a rumor, but I didn't know about this. So then if I tell those guys that now I tell you that this is a rumor, do you self-correct, or do you have some self-correction behavior? So we are currently looking into this kind of behavior. So for early detection of rumor, what we are doing is we are leveraging a deep learning framework where we are generating informations from both content as well as from the networks. So basically content, we leveraging the content of the post as well as the propagation tree of the retweets and replies which are generating these rumors. So in the first part, we are generating a textual embedding using a character CNN-like model, which essentially captured the distribution of named entities and hashtagging tweets. So basically, we have the tweets, and we try to keep the distribution of these named entities and hashtags in the tweets, so that it learn a representation of this, learn a vector representation of this tweet, and we then leverage these tweet embeddings to this tree structure embedding, where we also try to embed the reply and the retweet tree using a sort of CNN architecture. And once we have these two type of embeddings, one from the textual embedding and one from the tree embeddings, we can then combine these together by jointly optimizing using a shared layer at the end of the network, and then we can have like an efficient framework which as of now gives a high accuracy of around 90%, where the state of the art which we have compared, which we have still found, was around like 86%. I have also some further research interest which aligns to the ones which you guys are doing in your group. So which is basically detecting and removing bias in social media. So basically we have like, it's evident that we have opinion bias, media bias, which are specifically explicit. For example, like Fox News is leaning towards Donald Trump, whereas CNN is not. But this is basically, this media bias is very explicit, but some sort of biases are also present in the society or in the political domain, which are not explicit in nature. So we need to find out. So currently we are doing a sort of labeling through a knowledge graph, where we are doing a sort of we have the news article and written by some authors, and what we are trying to do is we try to label this as a biased article or not. So that the user who is reading this article should have, while reading this article, should have that opinion in mind that this might be a biased one. So you should have your opinion aligned in a different way than the author. Similarly, search bias is also present in society. So for example, in Google, if you search by like if you search keywords with word like Muslims, the next result or the top result which you see is like, are the Muslim terrorists or things like that. And this kind of bias is also present. So there was a recent report in social media, so which says that if you are using Google's Cloud Natural Language API and try to find out emotions or sentiment out of it, then if you use sort of words like I'm gay or I'm black person, and you'll get, and the Google API gives you negative sentiments. So basically, these kind of things are creating bias in the society. So since these are developed for more and more social media data and like the news articles and things like that, so already these biases are creeping into the system and polluting this whole system. So we need to detect and remove bias from this social media. That's all. And thank you for listening. And if you have some questions, I will be happy to answer.
All right. All right. We do have time for questions. Maybe you can see me.
Hi.
Maybe I will start questions. So you mentioned actually, so that, let me see, that in your hashtag compounding work, you investigate different features.
Yes.
And your insight was that these features reveal something about linguistic universalities. So I wanted to hear more about it. Is there some theories? I mean, why do these linguistic universalities exist, and what do they reflect about the human nature, about the human mind? Perhaps you have some thoughts on that.
Sorry, I didn't quite get the question, so it was interrupting between.
Okay, it was this is the technical issues of remote communication.
Yes.
You should be able to
type, right? I didn't bring my computer, unfortunately. So you mentioned in hashtag compounding, you mentioned that this the type of features you've discovered reflected linguistic universalities. So I wonder if you could say something more about it, something to reflect what it actually tells you about the human language, maybe about the human mind, maybe about the human culture.
Hello?
Yeah, can you hear?
Yeah, sure. Yeah, so basically, like, since I give an example initially, like how this abusive content and this harassing or the cyberbullying in network in Twitter are propelling users to leave. So basically, we see that such kind of the language is important for this scenario. So if you see that, so basically, I want to say that the way we talk or way we like frame our language or frame our content is important. So if we put a lot of information in it and try to put this in social media, maybe this content would not be popular. So we should have diversity also, which is captured by the features like word diversity or the topical diversity. So there should be diversity in it, but you should not be like put in a lot of information in this so that people get annoyed and then it won't be becoming more popular. So there are linguistic aspects, so which I'm trying to find out these behaviors in all kind of entities which I've been seeing, like the topics in Quora or the hashtag compounding, or even the in books also we are getting such kind of behaviors. Yeah.
Actually, one more question about your results about spam follower. So did you have in a spam follow network? Did you have the actual ground truth about spam accounts?
Yes. So we have like we use the Twitter's suspended accounts. Okay. So yeah, so Twitter suspended. So each account has been suspended or not at later time point, and then we use that as a ground truth for the study. But we also see that here we think that the Twitter's algorithm is the best, but I guess in our study, which we're still in progress, so which we'll be looking into the cases which are still there in Twitter, which are being classified by our system as spam, and still there in Twitter, and then we can say like which are performing better or not. So this kind of analysis also needed for further development.
Okay.
So thanks for the talk. In that study you mentioned you have edge weights for the spam followers. Where did you get the edge weights from?
Yeah, the edge weights is calculated from so we have some features corresponding to the nodes and the edge. So basically edges, if both of them are retweeting or mentioning, co-mentioning, so these type of features we found out, and then so basically this feature, there is a feature vector, and this is multiplied with the edge, which I am talking about. So this weight is basically learned, so that learned corresponding to the constant, the two constant which we have, which is basically force the system to bias or to get the more spammer in the network.
Oh, so that was not that was not a Twitter follower graph. It was a similarity graph between users, right?
No, this was a who follows whom network.
But you said that
So
the weights come from if they're similar as if they have similar activity or not. Is that true?
Yes, yes. And also, so as well as the so basically there are several features. So we have the similarity activities, we have the tweet frequencies. So all these spam-like behaviors are also captured by these features, which we didn't derive, but has been taken from earlier literature.
Okay. And then one last question. You mentioned in your comparison, did I hear right? It was word to vec or node to vec?
Derived by, yeah, it's from word to vec basically. So node to vec is essentially doing the same thing. Essentially take this from the word to vec. So it's basically it's essentially from word to vec. Yeah.
Okay.
Any other questions here? Okay.
So the big trending hashtag now coming from, I guess this area was the Me Too campaign. So I saw when you did your parts of speech, you focused more on the nouns and the verbs. But this is more of a like pronoun adverb. So I don't know if you had any thoughts of the expansion of that. I don't know if you're familiar with the Me Too hashtag.
So you mean formulating hashtags? Can you sort of repeat the question?
There was a New York Times article or post, I believe, about sexual harassment, assaults in like Hollywood or in the media. So from that, there was a recent Me Too campaign. So you'll see this hashtag,
Compound hashtag.
yeah, a compound hashtag that's like pronoun adverb. But I don't know if you had any thoughts on how that would fit into your earlier results when you're looking more at the noun or noun-verb.
Yeah, so basically like these act as a feature here. So we see that noun are more prevalent, but we have also the existence of other sort of compoundings. So these basically act as a sort of like feature value. So for each of these sort of compoundings, we have a list of features. Yeah, so like noun compounding is a one feature, combination is one feature, a noun adverb is a one feature, and things like that. Yeah. So I guess our system can be leveraged to tackle this kind of scenarios also.
Any other questions?
This is Emilio. Can I ask real quick, do you have any proposal for this future study that you are proposing about the biases?
Biases in the network? So basically, yeah. So for understanding so I told you for labeling this news articles, so where there may not be some explicit bias, but some inherent bias might be there. So what we are doing is so basically we think of this as a sort of building a knowledge graph. So we have we can bootstrap this network so we have the initial levels. We know like from source and target, like from the article to the person, some are explicit in nature. So once we have this network, we can with that you can bootstrap this network and then sort of do a sort of link prediction to identify the inherent edges in the network. Then with this network topology, we can build a more universal knowledge graph where we have both these negative edges or the negative sentiment edges or the positive sentiment edges, and then you can leverage this to relabel those things to the nodes in the network. So basically, we need to have a bootstrap mechanism. Then we need to have some kind of mechanism which will infer more edges. So basically, these are the inherent edges. So, and by that we'll find out like which which topics are basically getting more bias in its media. So, am I clearly,
Well,
or do you have some questions?
We are out of time for questions. We run out of time, but there'll be opportunities in one-on-one discussions over Skype to ask more questions from this for Suman, including actually, I have more questions about your approaches for bias, but I will reserve those questions for our one-on-one discussion. So thank you for braving the challenges of remote interview talk, and thank you all for joining us here in this conference room. And so the rest of you will look for messages from Carrie about scheduling one-on-ones to talk to Suman more. All right, thank you, Suman.
Thank you for coming.
Thank you. So, there, you can see me now, right?
Sorry, the lunch is at noon.
No?
Think you're going in the other. No, you should face
lunch at
that
Oh,
camera.
this?
That camera.
12:15, 12:20.
It's like it's very. The whole world is
Usually,
split,
like
so
the time that carry.
And then, is that on the 11th?
Which I did.
Is it on the
I
11th?
heard it up. Yes, I heard it.
I hate when people like send out stuff, but they never, she was like, oh, there's a lunch today. Okay, like, what time and what seat?
And I wanted to know which links were corrected on the web and which links were
It's like you start wandering around at that time.
Yeah,
You just
exactly.
stand and just like you see people leave, just kind of like follow them.
was corrected.
Send an email about an event, maybe
But
the
the
time
one-
and location.
Google Calendar was wrong, so
I see.
I informed Eric.
Thank you for asking.
Okay.
the question. I was like,